All right, guys. So follow up to the last little bit of notes on the greenhouse effect itself, the enhanced greenhouse effect, etc. One thing College Board would like for us to discuss too is what's called the global warming potential of the various greenhouse gases. All right. So if you recall in the last video, right, we listed some of those greenhouse gases. Right. So we got ourselves a little bit of carbon dioxide. We got some methane, and we got some nitrous oxide, and chlorofluorocarbons. All right, we're not going to include water vapor on this one, mostly because there's not really any significant anthropogenic sources of water vapor. Plus, water vapor has a very short residence time in the atmosphere. The vast majority of the water vapor in the atmosphere comes from evaporation off the ocean, something we don't impact very much. So we're going to focus in on these four gases, talk about what we mean when we say global warming potential, and then also how the relative abundance of these various gases contributes, in addition to their global warming potential, to the overall impact on recent warming. All right, so carbon dioxide, our most abundant of these gases, by the way, is our reference molecule. So basically, global warming potential is referring to the capacity on sort of like a per molecule basis to absorb and radiate infrared radiation. And also, I believe it takes into account how long that molecule stays in the atmosphere. Right, so it's a direct measure of molecule per molecule impact on absorption and re-radiation of infrared energy. All right, so carbon dioxide, for example, has a GWP of 1. It's our reference molecule. Now, methane, right, another really important greenhouse gas, has a global warming potential of approximately 23. Now, there's a few ranges that might occur in there, but 23 is a good approximation of the global warming potential of methane. That kind of, for lack of a better way to say this, as far as what you need to understand as AP environmental science students, that just means that a methane molecule is about 23 times better at absorbing and re-radiating infrared energy within the troposphere. All right, it's a pretty significant difference. Nitrous oxide has a global warming potential of about 310. Right, that's pretty crazy. 310 times more infrared energy could be absorbed and re-radiated by the nitrous oxide molecule than a single molecule of carbon dioxide. Now, CFCs are actually a class of compounds. There's different varieties of these, and so they range from around 1,300 to up to 12,000 for their global warming potential. All right, so at first glance, the way in which this is stated, it would look as though CFCs would far and away have the largest impact on the enhanced greenhouse effect, based on the fact that they are so much more potent on a per molecule basis at absorbing and re-radiating infrared energy. Now, another really important variable, right, that sort of flips this on its head is the abundance. Okay, so the abundance is referring to how many of those molecules are actually in the atmosphere. So for example, carbon dioxide has a global warming potential of 1 and an abundance of approximately 400 parts per million. It does fluctuate a little bit throughout the year, and it's probably even a little bit higher than that. But for this purpose, 400 parts per million is close enough. All right, methane, all right, got my cheat sheet here, has an abundance of approximately 1 to 2 parts per million. Right? That means there's more than 200 times the number of carbon dioxide molecules in the atmosphere as there is methane. So if we just take those two into account, right? One molecule has a global warming potential of 1 for carbon dioxide. One molecule of methane has a global warming potential of 23. But when you take into account just how abundant those molecules are compared to each other, carbon dioxide ends up having a much larger overall impact because there's so many more of those molecules. All right, so in fact, 60% approximately of the increase in our temperature and the increase in the amount of radiation that gets absorbed and re-radiated back to the surface comes from carbon dioxide, even though on a per molecule basis, it has one of our weaker values. All right, 20%-ish comes from methane. All right, so often in the world of climate change, you'll hear the two molecules that dominate the discussion are carbon dioxide and methane. That's because 80% of the measured warming, right, or the measured increase in the greenhouse effect, or the measured increase in infrared radiation that gets absorbed and re-radiated, which is causing that warming, 80% of that is from those two culprits, carbon dioxide and methane. Now, nitrous oxide, while fairly potent, is 0.003 parts per million, right? So while it's very potent on a per molecule basis, it is not very abundant in the atmosphere. It only amounts to about 6%, right, of our increased greenhouse effect. And chlorofluorocarbons, while exceptionally potent as a class of chemicals, right, it's a trace gas, very, very small amounts in the atmosphere, right? I actually couldn't find a good number that told me on a parts per million or parts per billion scale. But even though they're tiny amounts, they're still believed to account for about 14% of the overall increase in greenhouse effect. All right. So College Board would like you to understand what global warming potential means, right? CO2 has a global warming potential of 1, and while it has the smallest global warming potential on a per molecule basis, its exceptionally high abundance compared to the others still makes it the dominant greenhouse gas in terms of the enhanced greenhouse effect, right? Followed by methane, and then nitrous oxides and chlorofluorocarbons.